Hello everyone, welcome to yet another video of measurement and instrumentation. So in last class we have discussed about AC potentiometer types, and we have seen the construction and working of one of the AC potentiometer type, which is the polar type potentiometer. And finally, from the polar type AC potentiometer, we found that the unknown voltage will be unknown EMF can be found from the EMF induced in the rotor, and the value obtained will be like an E at an angle of phi. So where E gives the magnitude of the unknown voltage and phi gives the phase angle. So the answer will be in the polar form, and hence it is called as polar type potentiometers. Now if we want to measure the voltages in a rectangular form or in the Cartesian form, then we can use a coordinate type AC potentiometers. So a coordinate type AC potentiometers gives the output in coordinate form, which is nothing but the rectangular form, that is V plus V1 plus J V2. So we have the unknown EMF measured will have two parts. One is the real part and the imaginary part. So this is the construction of a coordinate type AC potentiometer. So in a coordinate type AC potentiometers, we have two potentiometers in a single circuit. So the first one is in phase potentiometers, which is used to measure the real part of the unknown EMF, or we can say the in phase voltage of the potentiometer unknown EMF. And we have another potentiometer which is called the quadrature potentiometer, which gives the quadrature value of the unknown EMF, or you can say it as the unknown imaginary part of the unknown value in imaginary form. So in phase potentiometer gives the real part of the unknown voltage, and quadrature potentiometer gives the imaginary part of the unknown EMF. And this coordinate type AC potentiometers will work for all the four quadrants. But how it can be done? We have a sign switch S1 and S2, which operates the voltages V1 plus JV2. So we have V1, which is the real part, and V2, which is the imaginary part. So the both V1 and V2 are made to plot at all the four quadrants by changing the switch position, sign switches from plus to minus. So the sign switch for in phase voltage is S1, and the sign switch for the imaginary phase is S2. And we have a dial S3, which has 4 steps for operating on all the 4 quadrants. And B dash and C dash are the slide wire contacts for moving the moving the jockey in order to achieve null deflections. And A is the galvanometer, which shows the null deflection. So here is the working. In a coordinate type AC potentiometer, we have two separate potentiometers which are caged in one circuit. The first one is in phase potentiometer, which measures the in phase factor, or we can say it as the real factor of an unknown EMF. The other one is named as quadrature potentiometer, which measures the quadrature part of an unknown EMF. The sliding contact A dash in the in phase potentiometer and B dash in quadrature potentiometer are used for obtaining the desired current. By adjusting the rheostat R and R dash, the sliding contacts, the current in the quadrature potentiometer becomes equal to the current in the in phase potentiometers, and the galvanometer shows null deflections. By changing the S1 and S2, which are the sign switches, we can change the polarity of the test voltage or the unknown voltages. So by doing so, we can get all the values of the 4 quadrants. There are two step down transformers T1 and T2 which supplies the potentiometers, and they are step downing the supply voltage 230 volt to 6 volts, and it also isolates the potentiometers from the supply side and gives an earth screen protection between the winding, and also it supplies 6 volts to the potentiometers. So here, to measure the unknown EMF, its terminals are connected across A dash using the selector switch S3. By doing some adjustments in the contacts and rheostats, the whole circuit gets balanced and the galvanometer reads zero deflection at the balance condition. Now the in-phase voltage component, which is V1, or we can say it as VA, of the unknown EMF is obtained from the in-phase potentiometer, and the quadrature component, which is here termed as VB, can be obtained from the quadrature potentiometers. So the resultant voltage gives the magnitude of the unknown voltage. And how we can get the resultant voltages? We know that V is equal to root of VA square plus VB square, where VA and VB are the real and imaginary part of the unknown EMFs respectively. And the phase angle can be obtained by theta is equal to tan inverse of VB by VA. So with this we can conclude this topic. So now we have a clear cut idea about what are polar and what are coordinate type potentiometers. So in the next class we will discuss about the advantages and difference between the AC and DC potentiometers. Stay tuned. Happy learning. Thank you.